Okay. So in addition to adding students to a list, all along we've been adding them to this array as well. This array essentially represents the state of our roster. Just the data. The fact that they're LIs and all that stuff, that's all just presentation. This is the real data. This tells us everything we actually need to know about the students. The order they're in, their IDs, their names, any other properties we would happen to add. If we needed to add a property, we could just go down here to where we create the student and add one. And they all get pushed onto this array. So supposing we want to do something like, I don't know, save them in local storage, the fact that we've already been doing this makes it much easier. So how do you think we could do that? If every time we add a student, we add these things to the array. We're using unshift now because we're adding them to the top, not the end. What if we said local storage dot set item? We could call it roster or mega roster, whatever. Or heck, we could just call it students, since that's what we call it here. Whatever you want to call it. Call it roster just to make it clear that it does not have to be the same name as anything else. We can call it whatever we want. And we set it equal to this dot students, that array. Now what do you expect that to do? Just what we want? No, probably not quite. Let's see what it does. Local storage dot get item roster object comma object. Yeah, not really what we wanted. So what if we just say JSON stringify right here? We store a stringified version of the students array every time that we add one to it. Let's try again. Local storage get item roster. Hey, that looks pretty good. It's still a string, but now there are my square brackets. So this is array syntax. And there are my three objects inside this array looking thing. I have double quoted keys and double quoted values, except for this one, which is a number. All valid JSON. And the important thing is it's a string, which is all that local storage knows how to handle. So let's say let roster equal JSON parse local storage get item roster. Let's check out this roster. Looks right. Pretty cool. So let's remove Akash. Nothing personal. It's just business. Now let's get this thing again. Didn't take him out, right? So we have to make sure we update storage every time we change that array. We did it when we add things, but we haven't done it when we remove things. So we would need to put it up here too. But we haven't even figured out how to take it out of the array, much less sync that array with local storage after we do so. All right, this removing from the array, this seems hard. How many people got this working? Everybody else try? Who didn't even try? Like you're going to raise your hand. Okay, who did do it again? All right. Liz, you want to tell me all about it? I'm sorry, you ended up a for loop. Okay. So a for loop to find, because the thing we're missing here is the index, right? All right, what's that look like? I'm not going to make you explain the syntax of a for loop to me, but we'll even do let I equals 0. Why let instead of const? Can people actually read this? Does it need to be one notch bigger? Do not be afraid to say it needs to be bigger. Okay. How's that? A little more? Good? Okay. Why let instead of const? Yeah, because it's going to be incremented. So it's not going to stay the same. But you may have noticed, we've done this lots of times. Const cars equals some object. Cars dot Italy equals Ferrari, Maserati, Fiat. Check out cars. That worked. Why? We didn't actually reassign cars to a whole new object. We just changed some values within it. And that you can still do with a const. They're not completely unchangeable. Const doesn't make them truly immutable. It just makes them so that they can't be reassigned. But you can change the values of their properties and add whole new properties, even with const. Which is much of the reason why we can use it almost all the time. All right, so I less than 0. Our array that we're looping over is this dot students, right? So this dot students dot length, I++. Then what do I do inside the loop? Okay, so this dot students sub I dot ID triple equal to the ID from the LI, is what you're saying, right? So we did this button closest student thing, which removed it, so the LI is already gone, so I need to do it before I do that, right? So let's say const LI equals button closest student. Let's not forget to do that. Okay, this students sub I ID equals li dot dataset dot ID. Is that what we're checking? So if that, so we know that li.dataset, that means this li tag, any attribute that starts with data dash. So data ID, data dot name, whatever. All of these things are part of this dataset object in the DOM. And they're accessible by the key, with the key being whatever comes after the dash. And if that's a multi-word thing, like first name, that would still be dataset dot first name camel cased. I think. Let's make sure that's not a vicious lie. Okay, we've got this H2 here. I'm going to say data First name equals Davy. Refresh the page. Inspect. Mega roster. There it is. I think I may have only shown this trick to the afternoon class. If you have something highlighted in the Elements tab, look at this, $0, you see that? That means that I can now access that element as $0 in the console. So I don't have to throw a debugger in some place that grabs it. I don't have to do query selector. I can just find it in this Elements tab and get to it. Super handy. So $0.dataset. Yep, it camel cased it, first name. Just like it does with style sheet properties. Okay, so if this student's sub I dot ID triple equals li.dataset.id, and what's the difference between triple equal and double equal? Triple equal actually compares the types of the two things. So while for is double equal to the string for, true. For is not triple equal to the string for. Those are two different things, and most of the time we would want that to be false. So we use triple equal unless we're really sure that we want to do the other, because there are side effects that are certain to pop up sooner or later. So, what if the yes? So one of them might be a string and the other's the other. So we'll deal with that when we come to it. Double equal is one of the ways we could deal with that. There are other ways we could deal with it too. So we'll see about that. So now what? So what if they do match? Like inside here, inside the if? Okay. This dot students dot splice I 1. We established that 1 is how many things it will remove, right? Otherwise it would remove all the way to the end. So for right now, we'll go ahead and make it a double equal to see what happens. Cannot read property ID of undefined at line 23. Which thing do you suppose is undefined? One of these two things. Probably li.dataset. Let's just throw in a debugger. So you understand how to use debugger? It'll pause execution at that point, and then we can start fiddling around with things. Remove. All right. Li is this Li. There's dataset. Dataset has an ID property. This is there. This dot students is there. It's an array. Cool. So that looks all right. We still get that problem. Now it's on line 24. So let's put the debugger inside our loop, since that's where the error is. Okay. Right. Yeah, our condition is wrong. I equals 0. I less than this.students.length I++. Refresh. Okay, no more errors. Still removes it from the DOM. Let's see what this.students looks like these days. Not this.students. From here, it needs to be megaroster.students, right? There's only two things in it. And they appear to be the correct two things in the correct order. See any other ways this could be improved? I mean, aside from like changing it to something other than a for loop. If we're leaving it a for loop, see anything else? Yeah. Okay, yeah, sure. So let's, again, just throw a debugger in here so we can look at these two things. So the things we want to compare are this.students sub I.id. Okay, it looks like the number 1. li.dataset.id, which is the string 1. So the way around it would be to convert them to the same thing. So either we could say this.students sub I.id.toString. ToString is something that is on absolutely every JavaScript object. It doesn't always give you what you want, right? It turns objects into object-object. You might guess it does the same thing. I mean, it does the right thing with a simple number. Another thing we could do, instead of converting that to a string, we could say parse int or parse float with the one that's a string. To turn it into a number. Let's see, is that triple equal to this.students sub I.id? It is. That's another way we could do it. We could also save this as a string in the first place. Any of those things would do it. Yeah.
For that for loop, what does it do when the I is 0? Isn't the first index, like, doesn't the data set ID start at 1 and the array would start at 0?
So I itself starts at 0, but remember that's just the index of the array. So this dot students sub I is just going to be the first item. And that first item's ID is going to start at 1. So we start max out at 0. But even the very first student that we save, we set it to max plus 1. Right? So we could decide to just make IDs a string. We could decide to turn them into strings before we compare them. We could decide to just use double equal. I don't like relying on double equal just because it's counting on a side effect. And that just sort of feels wrong on some level. It is certainly the easiest way to do this. Not that these others are particularly hard, but personally, let's see. We know dataset ID is always going to be a string because that's how dataset works. They're always strings. Students ID, maybe we don't know for sure, and maybe we don't want to rely on it being a particular data type, so we could just force whatever it is into a string. we know forcing things into a string is okay. So I could say let current ID equal that as a string. Then I could triple equal compare the two. Make a roster.students. Yeah. Enter does not autocomplete in the JavaScript console. It does in code, but not here. You have to use tab. All right. So that did the right thing. It removed one from the middle. So this is what I'm going to go with, just to emphasize the type comparison. Anything else you'd change? Let me ask you this. If I have 1,000 students in this roster and the very first one is a match, how many times am I going to go through this loop? I'm going to go through it 1,000 times. I'm going to keep looking because I didn't do anything to say stop looking. I just said if this one matches, go ahead and remove it. But keep going. I mean, you never know. Right? And we're going to say, according to our business logic, there's no way the same student's going to be in there twice. The IDs cannot be reused. Anybody know how to stop it from continuing through the loop? Yeah. Break. So if it's a match, not only are we going to remove it from the array, we're going to break out of the loop. So that's exactly what that does. Can you dig it? Now, we're still, if we get mega roster out of local storage storage.get item, we call it roster. It still doesn't delete it, right? So we need to update local storage. I don't really want to repeat this entire line, especially should we decide to change the key in local storage. So what I kind of want to do is add a method that does that for us. Keep it real simple. Let's just call it save. This dot save. Wouldn't that be nice? We just save it after we add one. We save it after we remove one. Just save the entire state of the application. And in fact, let's just move that. Oh, I'm copying it. Let's see. Trying to remember the keyboard shortcut for moving a line so I can teach it to you. Alt. Highlight something, hit Alt and the arrow keys, Option on a Mac, and you'll move that line. So we save it after that. We save it after we remove. Now, save just needs to exist. What's it going to do? It's going to set an item in local storage, roster, JSON stringify, this.students. Don't forget your comma. Save is just another property on this object. Let's refresh. Let's try it again. I'll use some real names this time. I'm terribly sorry. Your name again, sir?
Mine?
Yes. Evan, that's right. Evan Vishal? Lawrence. Remove the one in the middle because that's the most fun to test. First of all, let's check local storage right now. Okay, they're all there. Remove one. He's gone. Yay! Save students. I'm going to use our fancy word. Persist student data in local storage. Now, what do I mean? I mean that when I refresh the page, it's still the same in local storage. Now, it's not the same on the page, so we're going to have to fix that. But at least it's the same in storage. The storage persists across page loads. So we need to get it out of storage and add it back to the list when the page first loads. That sounds hard. It's not that hard. Let's make a method for it. We have save. How about load? Don't forget your comma. Instead of local storage set item, what are we going to call? Get item. Local storage dot get item. That item roster. And we know what's that going to give us? The object just as we need it? Not quite. It's going to give us a string, right? If we want to be real explicit here, we can call this roster string. To turn that into the actual array, what do we need to do? We need to parse it. JSON.parse is the opposite of JSON stringify. We need to parse this roster string. And then that should give us the original thing. So how can we make our application state match that? What goes at the beginning of this line? We should set something equal to this. Maybe. What? The whole point here, we're saving it and loading it back so that we can put it where? What stores, I'm sorry? In the array. This dot students. If we do that and refresh the page, well, we might need to make sure we actually run load, right? 0, set up event listeners. This dot load. Refresh the page. Now we know local storage is right. What about mega roster dot students? It's right too. Yay. No, they're not on the page, so fat lot of good that did us. But hey, it did do something. So how can we get them back on the page? Let's write a whole nother function that does that, right? Now, we've already done this work. What if we loop through this array and call add student or build list item or something like that? Seems like add student does all the work for us, right? Heck, it even puts them back on this array. So if I call add student right now add student presently expects an event, not a student. which, considering it's called add student, it's kind of a misnomer. So we could separate this into two functions, one to actually handle the event and one to add the student. And adding a student could just take a student object, and it would do both building the list item and updating the array. How does that sound? I like that. So we could call this handle submit or something like that. We could call it like add student via form. What do you want to call it? I kind of like that. Add student via form, that takes the event. Don't forget your comma. So that should prevent default. It should build this student object. And then maybe it should just call this dot add students, add student, student. And then this will take over. It takes a student object now. It'll unshift it. It'll find the list item. It'll prepend it. It'll increase our max, reset the form. Resetting the form probably should be the job of the actual event handler, not add student. That has nothing to do with adding student. It has everything to do with handling the form submission. What do you think? Make sense why I wanted to separate those things? Now there's more than one way to add a student. We could add a student because we submitted the form, or we could add a student because we got it out of local storage. Otherwise, I'd have to repeat all this logic of keeping track of the maximum ID and everything. But that's an interesting point. Let's see what's going to happen with these IDs. All right, so are you with me, more or less? So we need to make sure add student via form is the new event handler. So up here we have set up event listeners. When we submit this form, we were calling add student. Now we will add student via form. We're still going to need to bind this. Let's see what happens. Well, first, what was the point? Load. Now, instead of setting this.students directly, we can set another variable, const, we'll call it roster array. Then we can loop over that. We can use a for loop. What do we know about map? What does map do? Do you remember map? Roster array dot map takes a function. The function receives each item in the array. So we could call that student. Then we can do as we please with student, like call this dot add student student. Now remember, this is a new function, but this works because that's what arrow functions do. Arrow functions automatically bind this to whatever it was in its surrounding context. So we don't have to bind this little function. So all this function we made is doing is actually calling another function and passing in the exact same argument. So it kind of seems like maybe we could just say this dot add student. Is the function? The function that you pass as a callback in map will receive as its argument, or as the first argument anyway, the current item from the array, which will be a student with an ID and so on. Let's try it out. Refresh. Okay, right off the bat, it runs load and tries this stuff. Cannot read property unshift of undefined at add student. line 57. So this dot students, it says, is undefined. Why is that? We defined it up here. Could this be the wrong thing? It could. We're trying really, really hard never to refer to the object as mega roster from within that very object, because that's just the name we happen to have assigned it to outside. So we're really trying not to do that. So why would this be the wrong thing here? If we called add student this way with parentheses, then we would be calling it as a method, and this would get bound the way we expect. But it's a callback passed to map. So it's probably window, because we don't know that it was anything else. So if we want it to be right, we do have to explicitly bind it here. So we could do it this way, or we could do it the way I did it a minute ago and assign, put an arrow function in there. I don't know which you prefer. So let's make sure this really does work. Refresh. Okay, now they're on the page right as soon as I load it. Let's add someone else. There it is. Refresh the page. They come back. In the wrong order, but they come back. Pretty nice, pretty nice. So refresh one more time.
What are their IDs?
Yeah, that's a good question. So let's look at megaroster.students. Lawrence is 3. Evan is 1. Zach is 3. 2 of them ended up with the same one. Something's screwy with our ID logic. So let's start from a blank one. We'll have to remove these. If we refresh, now they're all gone. Just to be sure, megaroster students is empty. Local storage, get item, roster is an empty array. Good. Let's add. Sorry. I knew that. Let's add Tom. His ID here is 1. His ID in local storage is 1. Let's add Leo. In local storage, Leo is 2. Tom is still 1. Megaroster students. Leo is 2. Tom is 1. All right? Tom 1, Leo 2. And Leo should be at the top of the list. Refresh. Now Tom's at the top of the list. Tom has an ID of 1. Leo has an ID of 2. So the IDs are the same so far, right? That's what they were last time, right? If we refresh one more time, well, let's see. So that's that. Did local storage change? Well, the order is now the other way around. Because every time we call add students, we do call save again. Refresh the page one more time. Leo's back on top. Leo 2, Tom 1. Okay, so that seems okay. What if we add somebody else? Let's add Devin. Devin ID 3. Fine. Refresh. Order's wrong, but the IDs still seem to be okay. Let's remove Leo. Now let's add Matt. Matt has an ID of 4. Tom has an ID of 1. Devin has an ID of 3. Cool. Refresh the page. Now, we have 3, 1, and 4, just like we did. Let's add another one. And who's this guy? He's 4. We already used that, didn't we? Devin is 3. Tom is 1. Matt, also 4. What in brief is the problem? Max is getting to be the wrong thing somehow. When do we change it? After we add a student, we always increment it by 1. What if we have some high IDs already, even though we no longer have that many students? We're going to start reusing things, right? Because like now it's going to get incremented to 3, and the next one's going to be 4, but we already have an ID of 4. In fact, we already have it twice. So it seems like what we need to do is say if student.id is greater than this.max, then this.max equals student.id. So it'll always be equal to the highest ID, which is what we want, right? That makes sense? Because we know when we create another one, it's going to get incremented. I mean, it's going to be 1 higher than the current max. So we just want to make sure that we only increment max if, in fact, it needs to go higher. And that every time it does need to go higher, we really do. Not just every time we add a student to the list. So let's try to recreate that scenario. Okay, we've got 3 people. But our max is 4. Refresh the page. Now I've only got 2 people. The max is still 4 because that's this guy's ID. Did it remove the right one? Is that really the one I clicked? Refresh. Now Matt's at the bottom for some reason. Let's remove this guy. Refresh. Matt's back at the top. They keep changing, but now what's our max? It's 5. So Matt, we hope, is ID 5, right? Data ID 5. Looks like it. So now I believe the IDs are incrementing correctly. But we're still getting the order wrong, right? So how is that happening? So when we add one through the form, we want to add it to the top, right? So add student always adds it to the top with unshift. But how are they stored in local storage? In the order we actually want them to appear, right? And we're looping through them in that order. And then adding them to the front of the array. So we take the first item in the array, put it in there. We take the second item in the array and stick it as the first element in this.students. So we're storing them backwards when we load them from local storage, because local storage already has them in the right order. So somehow we have to deal with that. I'm going to go ahead and celebrate our victory here. Track max ID correctly. So do we understand the bug? Why it's wrong when it loads from local storage? So maybe add student needs a second argument that tells it whether to append or prepend. How about that? Let's just do that. Append will either be true or false. If append then this dot students push student, else the students unshift. But list item does it the other way too, doesn't it? Well, cuss. So we'll build our list item. Then if we're supposed to append, we will do this student's push student to add it to the end. And this dot student list dot append child, or student list is the UL, right? List item. Otherwise, we unshift the array, stick it on the beginning, and call our own prepend child. Getting a little complicated. Yeah. When we load, yeah, that's again sort of relying on a side effect, but it would totally do it. What do you think? It does simplify this. Let's try that. When we load it from local storage, we could say roster array dot reverse. Right, is that a thing? So we have mega roster dot students, which has Matt first. Mega roster dot students dot reverse has Devin first. Call reverse and then call map. Refresh. Refresh again. They stay in the same order. I like that better. Cool. Now it seems to be doing the right thing. Load students from local storage.